Hey everyone, welcome back to our YouTube channel. If you're new here, we are Code and Create. My name is George, and today we're diving into an exciting new project. We're going to build a complete movie app using React, Framer Motion, and Tailwind CSS. So if you're into building a real-world web app with interactive animations and modern styling, make sure to stick around. This app will give you access to some of the most popular movies, top-rated films, and upcoming releases all at your fingertips. On top of that, we'll be adding smooth animations with the help of Framer Motion to create a visually appealing and interactive user experience. These animations will make our app feel modern and sleek without being over the top, just enough to make it engaging for users. Now for technologies, we'll be building our UI with React, styling it with Tailwind CSS for quick, responsive design, and adding some sleek animations using Framer Motion to give it a polished feel. These animations will be dynamic and effective, and they will create a smooth and modern user experience without being too distracting. What's really cool about this project is that we'll be integrating an external API to fetch real-time movie data. This means we're not just building a static app, we're making it dynamic by pulling in data like movie titles, genres, release dates, and more directly from an API. This way, every time you load the app, you will see up-to-date information about popular movies, top-rated films, and upcoming releases. It is a great opportunity to learn how to work with APIs in a practical way, which is a crucial skill in modern web development. As always, don't forget to hit that subscribe button if you haven't already. Make sure to ring the bell so you don't miss any future videos. And if you find this tutorial helpful, please give it a like. And feel free to drop any questions or comments down below. We'd love to hear your thoughts. Now let's take a detailed look at the app we'll be building together. At the heart of our application is the movie listing section, where we'll display a collection of movies fetched from an API. We will use different categories like popular, top-rated, upcoming, and discover movies. Each category can be selected from a drop-down menu, and we have also built pagination controls, so users can easily browse through multiple pages of movie results. We are fetching this data in real time using an external API, and with each category the app updates instantly. Each movie is presented in a visually appealing card layout. These cards will show the movie title, genres, release date, and original language. What's cool here is that we are making the cards interactive using Framer Motion animations. When you click the card, it will reveal more details, like the movie's overview, and the hover effect will create a subtle, smooth transition that makes the app feel alive and dynamic without overwhelming the user. One unique feature we are adding is mouse tracking, where the background or layout shifts slightly based on your mouse position. It adds a little flair to the UI without being distracting. It is a neat way to bring some movement to the app and keep things interactive for users. We have built a custom navigation component at the bottom of the screen that lets you easily move between pages. On top of that, we've got a category filter dropdown that allows you to switch between categories like popular, top-rated, upcoming, and discover. This filtering functionality is essential in keeping the app intuitive and giving users control over what content they want to view. No app is complete without a good loading state. When the movie data is fetching from the API, the app will display a loading screen that ensures users know something is happening in the background. It is simple but important for a smooth user experience. We'll be integrating the movie database API from Rapid API to fetch movie details in real time. Not only will we be working with API keys and endpoints, but I'll also show you how to handle asynchronous data fetching and ensure that the app remains fast and responsive, even when the API is doing its thing. And that's an overview of the app. By the end of this tutorial, you will have a fully functional movie application that looks great, is responsive, and uses some cool animations. So now that you know what we are building, let's jump into the code. So I've gone ahead and created a new folder called Movie App, and as you can see, it is completely empty at the moment. Now let's open it in VS Code. And the first thing we need to do is to create our React application and set up Tailwind CSS for styling. But before we jump into that, I just want to make sure that you already have Node.js installed on your machine. If you are unfamiliar with Node.js, it is essentially a runtime environment that allows us to run JavaScript code outside of the browser. We need Node.js because it comes bundled with npm, Node Package Manager, and we'll be using npm to install and manage the dependencies for our project like React and Tailwind CSS. Now, if you haven't installed Node.js yet, it is super simple. Just search for Node.js, go to the official website, download the installer, and follow the steps. Since it is a pretty straightforward process, I'm not going to walk you through it here, but if you run into any issues, feel free to drop a comment below and I'll be happy to help out. Now that we've got Node.js installed and ready to go, let's move on to creating our React application with Tailwind CSS. For that, I'll be using a fantastic build tool called Vite. Vite is incredibly fast and makes setting up a development environment for frameworks like React, Vue, or Svelte a breeze. So let's go ahead and search for React Tailwind Vite. This will take us to the Tailwind CSS website, which has all the information you need about the framework. If you are new to Tailwind, I recommend checking out the documentation, but right now we are focusing on the installation steps. So here we will find the commands we need to set up the React app with Tailwind CSS. I'm going to copy the first command from here, then go back to the VS Code and open terminal. In order to open terminal, we need to press Ctrl plus backtick, or you can click View and then Terminal. Once the terminal is open, I'm going to paste the copied command and I'm going to change the name of the project. Let's call the project Movie App and then run the command. So once it is done, we'll have a brand new React application. It automatically generates a folder called Movie App with all the initial files and folders we need. I'll walk you through those in a moment. Now we need to install Tailwind CSS. Let's navigate into our project folder. For that we need cd, then movie app. And then I'm going to run the following command to install Tailwind CSS and some additional tools. We need npm install, then -d Tailwind CSS. Next we need post CSS and auto prefixer. Alright, so here -d flag means that these packages are being installed as development dependencies. That's because we only need Tailwind during development and build processes, not in the final production version of our app. Now let me quickly explain what these additional tools do. Post CSS is a powerful tool that processes your CSS through various plugins, allowing you to extend and optimize your styles. Auto prefixer, for example, is one of the most popular post CSS plugins, and it automatically adds browser-specific prefixes to your CSS, ensuring that your app looks consistent across different browsers. So once Tailwind CSS is installed, we need to initialize it and create a configuration file. Let's do that with the following command. We need npx tailwind css init -p. This will generate a new file called tailwind config.js, and we'll make a few small tweaks here to customize Tailwind for our project. Let's go to the browser and copy this code from here and replace the current code in Tailwind config file. We also need to update the index.css file. I mean this file here. Right now it contains some global styles, and I'm going to delete all the existing styles from this file and replace them with Tailwind's special directives. First I'm going to delete the content, then go back to the browser and copy those Tailwind CSS directives, paste them here. So here we have three different directives. The first one is base. It brings in some global styles and resets, ensuring a consistent look across different browsers. Then we have components. It includes pre-built component classes that you can use in your UI. And finally, we have utilities. This is the core of Tailwind, providing hundreds of utility classes to apply styles directly in your HTML. Now that everything is set up, let's run our application and see what we have. To start the development server, we have to run npm run dev. This will generate a local URL that we can open in the browser. You can either copy the URL or press Alt and click the link in the terminal. So as you can see, our project is up and running. I'm going to close those tabs and then I'm going to place the browser and the editor side by side in order to make our working process more convenient and simple. So as you can see, we have some default files and folders generated by Vite. Let me walk you through them quickly. In the public folder, we have an icon that comes by default with the project. This folder is typically used to store static assets that don't change during the build process, like images, fonts, or fav icons. However, we don't need this default icon for our project, so let's go ahead and remove it. Next, we have the src folder. This is where most of our work will take place. It contains the source files for our application, including assets and styles. Inside, there is an assets folder, which is where you would normally place images, fonts, or other media that your app might use. I'm going to delete this folder at all. We also have a file called app.css. This file contains some default global styles, but we'll be managing all our styles through Tailwind CSS, so we can safely remove app.css file. Instead, we'll be using index.css as our main style sheet, where we will configure Tailwind's utility classes and global styles. Moving on to the index.html file, this is the entry point for our application. It contains the div with the ID of root, where React will render our application. I will also go ahead and update the document's title. So instead of Vite plus React, I'm going to insert here movie app. Besides that, we have here a default fav icon. I mean this icon here. And I'm going to change it, replace it with our image. So I have here image called movie clapper. Let's drop it here in the root directory. And then instead of vite.svg file, I'm going to add here movie clapper.png. Besides that, we need to change here the type of the image. It's going to be png, not svg. Let's check the browser. So as you can see, now we have here our custom fav icon. Right now the page is empty because we have here some errors. As you remember, we deleted the icon from the public folder, and that's why we see here some errors, but we will fix that soon. Lastly, we have two important JavaScript files, app.jsx and main.jsx. Let's open main.jsx file. So it is the entry point for React. It is responsible for rendering the entire application into the root elements I just mentioned in index.html. We don't need to modify this file, so I'm going to close it. As for the app.jsx file, it is where our main React component lives. Right now it contains some default content, but we'll be clearing it out and building our app components from scratch. So let's go ahead and delete this entire content from here. To create a new React component, I'm going to use a super handy shortcut, RAFCE. So as you can see, a new functional component is created. So this shortcut comes from one of the VS Code packages called ES7 React Redux snippets. This extension, you can go ahead and install this extension and use the shortcuts. So as I said, a new functional component is created. Now I'll go ahead and delete this default import statement. We don't need it. And if we check the browser, then we will get here app, which is the content of the div elements inside the functional component. All right, So that's it for our initial setup. We've got our React app up and running with Tailwind CSS, and we're all set to start building the actual movie app components. So here in the src folder, I'm going to create new folder, and it's going to be components. And inside the components folder, I'm going to create new component, and it's going to be home.jsx. Then I'm going to create, again, a new functional component using RAFCE shortcut. Let's get rid of the import statement. Then go to the app.jsx file and import newly created home component. So we need here import home from components, and then we have to select home. Then instead of this text here, I'm going to insert newly created home component. We need to nest it here. Now if we go to the browser, then we will get home, which is the contents of home component. All right, let's go ahead and close those files. Then I'm going to open home.jsx file, and here I'm going to create some content. Instead of this text, I'm going to open here div elements. Then we need again div. Now we need to insert here a card, and for that we need to create a new component in the components folder. I'm going to call new component card.jsx. Then inside here we need to create a new functional component using again RAFCE shortcut. Let's get rid of this line. Then go to the home.jsx file and import newly created component. We need import card from card, and we have to nest it here inside the div element. So we need here card. Now if we go to the browser, we'll get here the content of the card component. Okay, now that's it about the home component. We don't need any other elements here. Let's open card.jsx and create here the content of the component. Get rid of this text from here. So we need div. Then inside div element, I'm going to open h1 heading element, and the content is going to be, let's say, the Godfather. Next, I'm going to insert here div elements, which will include spans. The first span is going to be genres. Then we need to insert here second span elements, and I'm going to insert here, let's say, crime, drama. Then after this closing development, we need to open span with the text original language. Then we need again span elements, and I'm going to insert here EN, which stands for English. All right, after that, I'm going to open again span elements, and it's going to be release date. Next, we need again span, in which I'm going to insert the date, let's say 1972 03 04. After those span elements, I'm going to open P, in which we'll have two spans. The first one will be summary. Next, we need again span elements, in which I'm going to insert summary text. So here we have the hard-coded data, and once we proceed, we will replace this hard-coded data with the dynamic one. Now the only thing that we have to do here is to insert image. Let's insert in the alt attribute movie image, and right now I'm going to open again this folder and put this image in the public folder. Let's add here the source. It's going to be image.png. Let's go to the browser. So as you can see, we have here the image and actually the entire contents of the card. Now it's time to start styling those elements. Let's go to the index.css file. And here I'm going to insert some global styles. Let's select body element. First of all, I'm going to define height, which is going to be minimum contents. Then we need width. I'm going to set it to 100 viewport width. And then we need background color. As the background color, I'm going to use 2, 4, and 4 zeros. So as you can see, the background color is changed. Now let's go to the home.jsx file and style those div elements. I'm going to start with the first one. We need here flex, followed by justify center and item center. Those two classes will allow us to center the content of the element. Next, I'm going to add here again flex, and then we need flex wrap, which will allow us to place the cards on different lines. Okay, let's go to the browser. So as you can see, the layout is slightly changed. Next, we have to customize the elements inside the card.jsx file. Let's go ahead and start with the first div elements. I'm going to add here class name. So first of all, I'm going to define height, and in this case, I'm going to use an arbitrary value. Let's insert here 650 pixels. Then I'm going to add here again flex layout. So we need flex followed by justify center and then item center. Besides that, I'm going to add here shrink with the value 0. Then we need padding 2 on all 4 sides. And also I'm going to add here a temporary background color. Let's say BG gray 600. Okay, so as you can see, the background of the card is changed. Lastly, I'm going to add here one more class, and it's going to be group. The group class in Tailwind CSS is a utility that allows us to apply styles to child elements based on the state of a parent element. It works by acting as a reference for group hover, group focus, and other similar pseudo-class utilities that can be applied to the children of the element with the group class. For example, if we want to change the appearance of child elements when the parent div is hovered, we can use group hover on the child elements, and those styles will only activate when the parent is hovered. This approach allows for much cleaner and more maintainable styles, especially in components where multiple elements need to react to a single interaction. Let's go ahead and customize the second div element. Add here class name. So here I'm going to define width and height. Let's set width to 97%. Again, we need here an arbitrary value. The height is going to be 97% as well. Then I'm going to add here margin auto to place the content in the center. Next, we need to change the text of the element. It's going to be white. Also, we need here position absolute. And then I'm going to add here position relative for the parent element. So after position absolute, let's add here rounded LG. Then we need background to be black, but with the opacity 50. Then I'm going to use again flex layout. So we need flex followed by flex column. We're going to change the direction of the flex layout. In this case, flex items will be placed vertically in a column. Then we need justify center. Also, I'm going to create some gap using gap y2. Then we need padding 10 on all 4 sides, and finally cursor pointer. All right, let's check the results. So now, as you can see, our card looks much better. After that, I'm going to customize the h1 heading element. So let's add here class name. I'm going to increase the font size using text 4XL. In this case, the font size is going to be equal to 36 pixels. Okay, next we have div after h1 heading element. So let's add here class name. In case of that div element, we need again flex layout. Then I'm going to create some gap on the horizontal axis. We need gap x2. and then item center. Alright, after that we have some span elements. Let's go ahead and customize them. Let's start with the first one. We need here class name. So for the first span element, we need text LG. Next, I'm going to customize the second span element. Let's add here font, semi-bold, and then we need text red 600. So as you can see, the second span element is customized. After that, I'm going to customize other span elements as well. Let's add here class name. We need flex, then gap x2. Next, I'm going to customize this span element here. We need margin right to be 2. And also, I'm going to make the text uppercase. After that, I'm going to customize the release date. So let's add here class name, flex, followed by gap x2. And then I'm going to change the style of this span element. We need here class name. Then I'm going to add here margin right with the value 2. As for the color of the text, it's going to be text yellow 400. Okay, so that's it about the span elements. They look good. And now we have to customize the paragraph. Let's add here class name. I'm going to use again flexbox. We need flex. Then I'm going to change the direction of the flex layout. Let's add here flex column. And then we need gap y1. After that, I'm going to customize this text here. Right now we have here just summary text, 2 words, but we'll replace this hard-coded text with a dynamic data. So first I'm going to add here class name with text red 500. And then I'm going to customize the second span element. Let's add here class name. I'm going to create here a little indentation using first letter, pseudo class. Then we need PL, padding left, with the value 2. So as you can see, we have here a little space next to summary text. The last thing that I'm going to do is to customize the image. So I'm going to add here class name. First of all, I'm going to fit the image in the container using object cover. Then we need rounded XL to make the corners of the image rounded. Next, I'm going to decrease the opacity. Let's make it 50. And now I'm going to use class group, which we added to the first development, which is the container of the content inside the card. So we need here group hover. And on hover, I'm going to change opacity. Let's make it 100. Then in order to make this effect smoother, let's use transition, opacity, and then we need duration 500. So as you can see, we have here nice hover effect. Okay, now let's go ahead and make a few modifications to control the width of the cards and their layout. Right now, our card widths are being handled in a fairly static way, but what we want to do is define the width dynamically, so we have more flexibility when we adjust the layout. We will start by creating a couple of state variables in home.jsx file to control this. So first we're going to define a state variable called card width. Let's add here new state variable, call it card width. Then we need an updater function, set card width. It should be equal to useState hook, and the default value is going to be 500. Next, we need to import useState from React, otherwise you will get an error. So this state variable will hold the width of each card, and we are setting it to 500. This gives us a good base size for our cards, but by keeping it in a state variable, we can easily adjust the width later if needed. Next, we'll define how many cards we want to display in a single row. I'm going to create a new variable. Let's call it cards in row. It's not going to be a state variable. It's going to be just a regular variable. Let's make this variable equal to 5. So this means that we are aiming to display 5 cards per row. Now, to make sure the container or wrapper that holds all the cards is wide enough, we need to calculate its width dynamically. We'll create another state variable, and it's going to be wrapper width with an updater function set wrapper width. So it's going to be equal to uState. And as I said, we need a calculation card width multiplied by cards in row. So by multiplying the number of cards in a row by the width of each card ensures that the wrapper will automatically adjust to the number of cards we want to display and their widths. So since the card width is set to 500 and cards in row is set to 5, the wrapper width will be 2500 pixels. Next, we'll apply this wrapper width to the wrapper div elements. So I'm going to add here style, and inside here we need width with the value wrapper width. This way our wrapper will dynamically adjust based on the number of cards we want to fit in a row. This is important because we want our layout to be flexible and adaptive rather than hard-coding the width. So with this approach, if we ever decide to increase or decrease the number of cards in a row, we only have to change the cards in row variable and everything else will update accordingly. Let's go to the browser. So as you can see, we have here a scroll bar because now the width of the wrapper is equal to 2500 pixels. Now let's move on to the card component itself. We need to pass the card width value as a prop to the card component. So here I'm going to insert card width, and the value of card width prop is going to be card width. So adding the prop to the card component will allow us to make sure each card knows its specific width and can adjust accordingly. Inside the card.jsx file, we will extract this card width prop by including it in the function parameters. So here I'm going to insert card width. This will give us access to the width within the card component, and we can now apply it to the outer div element of the card. We will update this style to dynamically set the width using the card width value. So here I'm going to add style, and then we need width with the value card width. This way, every card will have the same width that we defined earlier, ensuring consistency across the entire row. After that, we're going to take care of the image within the card. To make sure the image stays nicely contained inside the card, we're going to set its position to absolute. So let's add here position absolute. This will allow the image to fill the card without being affected by the padding or other elements inside. Then we will set the width and height of the image to 97%. So we need here width with the value 97% and then height with the same value 97%. We're doing that to make sure it fits nicely within the card with just a small margin around it to give it a clean, polished look. These values help ensure the image takes up most of the card space while leaving a slight gap for aesthetics. So let's go to the browser. Actually, something's wrong here. Let's go back to the VS Code and check the code. So here everything seems to be correct. Actually, we have here a typo. We need width. Now it should fix the problem. Okay, so now the problem is fixed. Before we proceed the coding, let's talk about Rapid API, which is the platform we'll use to integrate real-time movie data into our application. Let's head over to Rapid API's website. I'm going to search for Rapid API. and then take a quick look around. So Rapid API is one of the largest API marketplaces out there, bringing thousands of APIs together into one place. This makes it super convenient for developers, as you can find APIs for pretty much anything you need, from weather data to language translation, and in our case, movie information. Rapid API also makes it easy to test, subscribe, and integrate these APIs into your projects, so it is a fantastic resource for anyone building data-driven applications. Here you will see a well-organized interface with categories that cover a wide range of APIs, from finance to entertainment to health and everything in between. Since we are focusing on movies, we will use this site to find an API that provides us with up-to-date movie details. Before you can access any API on Rapid API, you will need to sign up. This is a quick and straightforward process. After signing up, you will land on a screen that asks for a few basic details like your name, coding experience, and how you plan to use Rapid API. This information helps Rapid API better understand its user base, so it is valuable feedback for them as a platform. Once you've entered those details, you will be directed to the API Marketplace. Rapid API organizes everything into categories to make browsing easier. To find our movie data, let's go to the categories and search for movies. Next, we need to click Browse Category, and here you will find a range of APIs providing all kinds of movie and TV data. We'll be using the TV show API for our project as it offers a solid set of movie data that will suit our app perfectly. When you click TV show API, you will be taken to the API documentation page. This page is like the control center for this API. It contains detailed information about each endpoint or specific route that this API offers. Think of endpoints as doors into different sets of data. For instance, one endpoint might give you popular movies, another might provide top-rated titles, and another might list upcoming releases. Each of these endpoints allows us to pull in different types of movie data that we will display in our application. On the right side of the page, you will see code snippets provided by Rapid API, which give us an easy way to start using this API in our code. Here is where Rapid API makes things very user-friendly. You can select targets and client from drop-down menus. In our case, we have JavaScript as the target. As for the client, we need fetch. Fetch is the standard method in JavaScript for making HTTP requests. This setup essentially generates the code we need to connect our app with the API in the simplest way possible. With these selections made, Rapid API generates the following code snippet for us. Let's break down what this code does quickly. The URL variable defines the specific endpoint we're accessing. In this case, it is the now playing endpoint. I mean, this endpoint here. As you can see, we have here now playing. It provides data for movies that are currently in theaters. We can change the endpoint from the left side menu. As you can see, we have here different endpoints like top rated, popular, upcoming, discover, and so on. Next, we have the options object. It specifies the request type and includes headers for authentication. Notice the headers contain our API key, I mean this key here, which Rapid API automatically generates for us when we sign up. This key is essential because it identifies us as authorized users of this API. If you look to the left side of the API documentation page, you will find your unique API key, which you will need to add to the headers. To make the actual request, we're using the fetch function, but you will notice that it is prefixed with the await keyword. This is part of JavaScript's asynchronous operations handling. When we call fetch, it doesn't return data immediately. Instead, it returns a promise. With await, we are essentially telling JavaScript, pause the function here until the promise resolves and we have the data. This way, we can proceed with the result only once it is ready, making our code flow much more smoothly. To use await, the function needs to be marked as async and we'll see that once we integrate this code to our function. The fetch function takes two main arguments here, the URL and options object. The URL specifies the API endpoint we want to access, while options contains important details like the HTTP method, get in this case, and the headers needed for authentication. Now, response is not the data itself, it is actually an HTTP response object. This object contains not only the data from the API, but also metadata about the response, such as the status code and headers. So at this point, we have received a response, but it is still wrapped in this HTTP object, and we need to extract the actual data. That's where this second line comes in. This line converts the HTTP response into a format we can work with, in this case plain text. By calling response.text, we are asking JavaScript to read the body of the HTTP response as text. Again, we use await here to ensure JavaScript waits until the entire response body is read before moving on. This text data is then stored in the result variable, and it's now ready for us to use in our app. Finally, our fetch call is wrapped within a try-catch statement. The try block attempts the code that might throw an error like our API call. If the request is successful, the data is logged to the console, but if there is an issue, like a network error or an invalid API key, JavaScript jumps to the catch block, where we can handle the error gracefully. This prevents our app from crashing and lets us manage any issues, such as by logging the error message. We will use this data to display movie details in our app. This setup makes connecting our React app with the API fast and straightforward. Before we can actually use the API, though, we need to subscribe to it. Actually, if you are newly signed up, you will see here subscribe button. So you have to click on that subscribe button. Rapid API offers various subscription plans, and we'll be choosing the free plan for now. This plan allows us to make a certain number of requests each day at no cost. In our case, it allows us to make 1000 requests each day. So once you have subscribed, Rapid API lets you test the API and explore the kind of data you'll be working with. To do this, we have to click Test Endpoint. When you test the endpoint, you will get a sample response from the API. The response data we receive from the API is formatted as an array with 20 items, where each item represents a movie. Each movie object includes key details such as the ID and title of the movie, its release date, an array of genres, the overview or description, an image URL, and so on. This response is essential for our app as it provides us with the data needed to display each movie's details dynamically. We'll be using this array of movie objects in our application to bring the UI to life with real-time information straight from the API. Before we get started on integrating the API, let's take a quick setup step that will make working with our movie data easier down the line. We're going to create a state variable called movies to hold the data we get from the API. So let's go to the home.jsx file and create new state variable. I'm going to call it movies. Then we need an updater function, setMovies. It should be equal to uState, and the default value is going to be an empty array. So why do we need this state variable? Well, when we fetch data from an API, that data is dynamic. It can change based on what's currently in theaters, which page of results we are on, or the type of movies we are filtering for. In React, we use state to store data that our component might need to update or re-render when it changes. In our case, the movies state will hold the array of movie data that we fetch from the API. And every time we get new data, we will update this state to keep the displayed movies current. This empty array will be our starting point, essentially acting as a placeholder until we populate it with real movie data. As we fetch data from the API, we will store it in the movie state by calling the setMovies function. This allows us to dynamically display movie data in our app since any changes to movies will trigger a re-render of the component, updating the displayed movies in real time. Alright, so the next step in our setup is to use the useEffect hook. In React, useEffect is incredibly useful whenever we want to run certain code at specific points in a component's lifecycle, like when the component mounts, updates, or unmounts. Since we are working with the data that needs to be fetched from an external source, in this case our API, it is essential that we only initiate this process when the component mounts and avoid refetching unnecessarily. So let's go ahead and create useEffect hook. We need to insert here a callback function, and I'm going to add here second parameter, which is a dependency array. Next, we need to import useEffect from React. So within useEffect hook, we're going to create a function called getMovies. This function will handle the actual API request and retrieval of movie data. It will request movie data from the API, process the response, and store it in our state variable. So let's go ahead and create a function called getMovies. Now we need to add the code snippet from the Rapid API website to this getMovies function. So here click code snippets, then copy this snippet and add it here inside the getMovies function. Next we need to add here a keyword called async, otherwise we will get errors. So what does async do and why do we need it here? When we are working with the data fetching, we are performing an asynchronous operation. This means the function doesn't return data immediately, but instead waits for the response, which can take time depending on network speed, server response, and so on. By marking the getMovies function as async, we let JavaScript know that this function will contain asynchronous code that might pause and wait for certain operations to complete. As you already know, inside the async function, we use await keyword to pause the function until the data is fully fetched from the API. Once we have this set up, we will call getMovies within useEffect to kick off the data fetching process when the component mounts. So here inside the useEffect hook, I'm going to call getMovies function. To see if everything is working as expected, let's check the response in the console and ensure that the data is coming through correctly. As you can see, we have here console.log with result. So I'm going to go to the browser and then inspect the page. Let's go to console. So as you can see, we have here a response provided as a plain text. So if we change the text function to JSON, then we'll get a response in JSON format, the one that we had in the API website. I mean the result of the API call. So as you can see, we have here array with 20 items, and each item includes ID, genres, image, original language, title, and so on. Alright, so now that we have our API connected and data fetching in place, let's move forward with displaying this data in our application. We will start by updating our movie state variable with the data we receive from the API. So first let's update the movies state by calling setMovies function. Actually, we don't need here capital S. Let's change it here as well. So as the value, I'm going to insert here result. As you see, result is a response that comes from the API call. Alright, so this line takes the data we fetched from the API, which we have stored in result, and updates our movie state variable. By updating this state, React will automatically trigger a re-render, allowing us to display the updated list of movies in the UI. Now that movies contains an array of movie objects, let's map through this array. So down below, I'm going to open curly braces and use map method with movies. Inside here, we need a callback function with two parameters, movie and I, which is the index. So by mapping through the movies array, we are able to loop through each movie object in the array, giving us access to each movie's data individually. The map function provides two parameters here, movie and index. The movie parameter represents each individual movie object in the array, giving us access to each movie's data, while index represents the index of each movie within the array. Inside the map function, we will include a div element for each movie, and inside this div element, we will have card component. So I'm going to grab this element from here and paste it inside the map function. Actually, instead of curly braces, we need here parentheses. Let's get rid of this semicolon from here. Okay, so now everything's correct. To make sure each div element is unique to React, we'll also add a key prop to the div elements. So we need here key with the value index. Again, I represents the index of each movie in the array, and giving each div a unique key helps React manage the rendering process more efficiently, especially if the list changes in the future. All right, let's go to the browser. So now, as you can see, we have here 20 cards, 5 cards in a row. Right now, all of them has the same data, but we'll replace this data in a minute. So everything works fine, and now we have to pass the movie data to the card component so that each card receives the information it needs to display. We will do it by adding a new prop to the card component, and it's going to be movie with the value movie. This prop essentially sends each movie's data to the card component, making it accessible within the component. Now let's head over to the card component to retrieve this data. Inside the function, we will extract movie prop. So this gives us direct access to the movie object within the card component. So we can now use the movie's individual properties to display the actual data. To make accessing the data easier, we will destructure the movie object. This involves creating variables for each property we want to use. So inside the function, I'm going to destructure the following variables. We need title, then image, genres, original language. Next, we need release data, dates, not data, and also overview. Those variables should be equal to movie. So again, we are destructuring those variables from movie object. So again, this line will pull out the specific properties we need from movie, making them easily available to use directly in our JSX without repeatedly writing movie.property. With these variables ready, we can now update the JSX to replace any hard-coded values with the dynamic data from our API. First, we will replace the movie title. So instead of this hard-coded title, we need here just title. It now reflects each movie's actual title from the API data. Next, we need to work with the genres. And since genres is an array containing multiple genres, we'll map through it. This means we will loop through each genre in the genres array and display it individually. So here I'm going to insert curly braces. Then we need genres.map with a callback function in which we'll have two parameters, genre and index. So here the map function provides two parameters, genre and index. The genre parameter represents each genre within the genres array for that particular movie, while index represents the index of each genre in that array. Inside the map function, we will include a span element to display each genre, and also we'll add key prop to each span to keep them unique. So I'm going to grab this span element from here and paste it here. And as I said, we need key prop with the value I. Okay, so now we have to get rid of this hard-coded text and we have to insert here genre. Let's go to the browser. So as you can see, now each movie has different name, and also each movie has different list of genres. Let's go back to the VS Code and change other data. Next we have original language, and instead of en, I'm going to insert here original. Actually, we need original language. Next we have release date, so let's change it as well. We need release date. Also, we need overview instead of this summary text. And finally, to display the movie image, we'll update the source attribute to use image. So we need here image as the source attribute. Let's go to the browser. So here we go. We have here different cards with different images, titles, and other data of the movies. All right, now let's go ahead and add an interactive effect to our movie cards so that the movie descriptions are hidden by default and only appear when we click on a card. This is where Framer Motion comes in, allowing us to add a smooth transition that reveals the description only when needed. To start, we need to control the visibility of each movie's description, and we will do this by creating a new state variable called showDescription. So here inside the card.jsx file, I'm going to create new state variable, and I'm going to call it showDesk. Actually, we need here show, not shoot. Then we need an updater function set showDesk. It should be equal to useState with the value false. Also, we need to import useState from React. Okay, so by setting showDesk to false initially, we are indicating that the descriptions should be hidden by default. Later, we will update this value when the user clicks on a card, which will make the description appear. Next, we will add an onClick event handler to the div element that wraps each card. So we need onClick event handler for this div element here. I'm going to pass here a callback function, and then I'm going to use setShowDesk function, and as the value, I'm going to insert not showDesk. So what's happening here? By setting onClick to setShowDesk with the value not showDesk, we are telling React to change the value of showDesk to its opposite every time the user clicks. If showDesk is currently false, this code will switch it to true, and if it is true, it will switch it back to false. This toggling behavior allows the description to show when showDesk is true and to hide when it is false. Now that we've set up the visibility control, it's time to install Framer Motion so we can add a smooth transition effect when showing and hiding the description. So let's go ahead and install Framer Motion. For that, we have to open new terminal. Then we have to navigate to our working folder, which is movie app. And here we have to run the following command: npm install Framer Motion. So once it is installed, we will import motion from Framer Motion, which is the core component we will use to animate our elements. So here we need to import motion from Framer Motion. You can think of motion as a version of a standard HTML element like div that comes with built-in support for animations and transitions. So by using motion, we can create animated elements that respond to changes in our component's state. Now that we have motion imported, let's go ahead and wrap our div element with motion div. So here we need to add motion dots. So this tells Framer Motion that this particular div will include animations. We will add 3 key attributes to control how the description appears and disappears smoothly. Those attributes will be initial, animate, and transition. So let's go ahead and start with the first one. We need initial I'm going to insert here opacity with the value 0. So the initial attribute defines the starting state of our animation. Here we set opacity to 0, meaning the description starts off fully transparent. After that, I'm going to add here animate. And in here, I'm going to use again opacity. And now we have to pass here a conditional statement. We need show desk followed by the ternary operator. If the show desk is true, we need 1, and if it is false, we need 0. So the animate attribute defines the end state of the animation. Here is what's happening. If show desk is true, opacity will be set to 1, making the description fully visible. If show desk is false, opacity will be set to 0, making the description invisible. This conditional logic allows the opacity to change depending on whether show desk is true or false. Now, after animate, we need transition. And here, I'm going to insert duration with the value 0.2. The transition attribute defines the speed and smoothness of the animation. Setting duration to 0.2 means the transition between visible and hidden status will take 0.2 seconds, making it quick but noticeable. Alright, so now that we've set up the animation, we can get rid of this temporary background color from here. Next, I'm going to add here Tailwind class called backdrop blur XL, actually to XL. So this class applies a high level of blur to the backdrop behind the description, creating a smooth, frosted glass effect that enhances readability and focuses attention on the description. So let's go to the browser and check the results. Actually, we don't see here the description. So this is because of the stacking order of the elements. And to fix this, we need to add the index with a negative value to the image. We need -z with the value, let's say 10. So this sets the image z index to -10, pushing it further back in the stacking order. Without adjusting the z index, the image sits above the description, blocking it from view. By pushing the image back, we ensure that the description appears clearly on top when show desk is true. Now if we go to the browser and click the cards, we will get this nice and cool effect. So as you can see, the descriptions appear once we click the cards. Okay, so everything works perfectly. And now it's time to add a navigation feature to our application. Navigation is essential in any application, especially one displaying a list of items, as it allows users to move through different pages or sections of content. In our movie app, navigation will make it easy for users to explore different categories of movies, move between pages, and switch views to find exactly what they are interested in. To start, we will create a new component called navigation. Let's open this component and, as usual, create new functional component using RAFCE shortcut. Let's get rid of this line of code. Next, I'm going to import our new navigation component into home.jsx file. Let's duplicate this line of code and change the name of the component. We need here navigation. So once it is imported, we will wrap the contents inside the home.jsx file with React fragments. So this syntax represents a React fragment. React fragments allow us to group multiple elements without adding extra nodes to the DOM. So instead of adding an additional wrapper element like a div, which might affect styling or layout, React fragments let us combine elements invisibly, keeping our code clean and maintaining the layout as intended. After adding our fragment, now we will insert navigation just above the main wrapper div elements. So let's add here navigation. After that, we have to build the basic structure for navigation. So let's go to the navigation.jsx file. So inside here, we have to add two sections, div for our navigation arrows and page number, and a drop-down to select different movie categories. Let's go ahead and add the content to the navigation component. So here we need another div element in which I'm going to insert span. This span element will include the left arrow, and right now I'm going to insert just the text left arrow. We will change this text with the actual icon in a minute. So after the span elements, we need paragraph in which I'm going to insert 1 as the page number, and then we need here another span for the right arrow. All right, after that, I'm going to open select element. We don't need name and ID. Inside the select element, we need 4 options. So let's open option. The value is going to be top rated. And as the text, I'm going to insert here top rated. Let's duplicate this line of code 3 times. So the second option is going to be popular. Let's add here popular. Then the third option is going to be upcoming. Let's add here upcoming. And finally, we need discover. Let's add the text discover here as well. Okay, so once the basic structure is in place, we will swap out our hard-coded arrow text with the actual icons to create a more polished look. For this, we will use React Icons, a popular library that provides access to a wide range of icons, including those from Ioni Icons. React Icons is very handy for adding scalable, customizable icons to our project without needing to import entire icon sets or additional images. So the next thing that we have to do is to install React Icons, and for that I'm going to run the following command. We need npm install react-icons. Alright, so once the installation process is done, now we need to import icons from React Icons library. So right above the function, we need import. And inside here, I'm going to specify 2 different icons. The first one is IOMD arrow drop left circle. Let's copy this name, paste it here, and change left to right. We need to import those icons from React Icons /io. So now we have to replace those hard-coded data with the dynamic one, I mean with the actual icons. So instead of left arrow, we need here to insert components with the name IOMD arrow drop left circle. Let's grab these components and add it here as well. Instead of left, we need right. Now, if we check the browser, then we will get here 2 arrows. Right now, they are not quite visible, but you can see here both arrows are displayed. Okay, so now we have to style those elements. Let's start with the second div element. Let's add here class name. I'm going to define the position of this element as fixed. Next, we need bottom with the value 5, which is 20 pixels, and then we need left position with the same value. Besides that, we need position relative for the parent elements. Let's add here relative. And also I'm going to add here the index property with the value 10. Let's go back to this second div element. So the next thing that I'm going to do is to use flexbox. We need flex followed by item center. Then we need to create some gap on the horizontal axis using gap x2. Then we need to increase the font size of the text. Let's set text to 2XL. Then we need background to be yellow, 500. Actually, we need here yellow, 500 with opacity, 50. Next, we need to make the element rounded using rounded full. And finally, we need padding on the horizontal axis using px2. So as you can see, the pagination is placed at the bottom left corner of the page. Next, I'm going to customize the span elements. I mean both span elements. Let's add here class name, cursor, pointer. After that, I'm going to customize the paragraph. Let's add here class name. So in case of paragraph, we need to use text XL. And then I'm going to add here select with the value none. It means that we use here user select property with the value none. All right, so finally we need to customize the select elements. Let's add here class name. First of all, I'm going to define the position of the element. It's going to be fixed. Then we need top 5, then left 5. This element will be placed at the top left corner of the page. Then we need background. It's going to be gray, 200, and the opacity 90. Then we need text SM. Also, I'm going to create some space between the letters using tracking white. Next, I'm going to change the color of the text. It's going to be text gray, 700. Then I'm going to make the text uppercase. Also, let's make the element slightly rounded using rounded MD. Get rid of default outline using outline none. Also, I'm going to create some padding on all 4 sides using P1. Next, I'm going to set cursor to pointer. And finally, let's create a little hover effect using hover pseudo class. We need background gray, 200. Let's check the result. So, as you can see, we have here this nice select element with 4 different options. Okay, so everything works fine so far. The next step is to make our navigation functional so that users can browse different pages and filter by categories. To do this, we have several steps like creating state variables, adjusting our API URL, configuring environment variables, and so on. So let's go through this step by step. First, let's set up 2 state variables to manage the page and group values for our application. I'm going to go back to the home.jsx file and create state variable, which is going to be page with the updater function setPage. It's going to be equal to uState, and the default value is going to be 1. So the first state variable, page, will start with a value of 1 because that's the default page we want to display initially. By tracking the current page in a state variable, we'll be able to move between pages easily, incrementing or decrementing the page number whenever the user navigates forward or backward. Next, I'm going to create the second state variable, and it's going to be group with the function setGroup. The default value is going to be popular. So this second state variable group will start with the value popular. This group variable will store the selected movie category, allowing us to dynamically change which category we're displaying in the application. Together, page and group will allow us to navigate through different pages and categories smoothly. Now, we need to adjust the URL in our getMovies function to reflect these variables dynamically. First, we need to replace quotes with template literals. I'm going to wrap this URL with backticks. Then, instead of hard coding the category, we'll use group. So we need here $sign with curly braces, and I'm going to insert here group. So this will automatically update the URL based on the selected group. Similarly, instead of a fixed page number, we will use $sign, curly braces, and page. So this will keep our current page updated in the URL. To make the API integration more secure and configurable, let's store the API key and base URL in an environment file or env file. Environment files are used to store sensitive information and configuration details outside our code. This keeps our project secure and makes it easier to manage settings across different environments, such as development or production. So I'm going to create a new file in the root directory with this name .env, and inside here I'm going to add two variables. We need with underscore API underscore key. It should be equal to the API key, I mean this API key. Let's copy those characters and paste it here. And then we need with base URL. So the base URL is going to be this portion of the URL. So let's copy it and paste it here. So by using prefix with, we make these variables accessible in a with project, which is required for with to load environment variables. Once we have our environment variables, let's go ahead and import them in home.jsx file. So we need to create new variable. It's going to be API key. And in order to import the API key from env file, we need to add the following: import.meta.env, and we need here the variable name with API key. Let's duplicate this line of code. We need here base URL, and instead of API key, I'm going to insert here with base URL. Next, we have to update the URL here in getMovies function. So instead of this part of the URL, I'm going to insert $sign, then base URL, and here instead of this API key, we need just API key, the variable that we created here. Okay, so I think that's it. This way, we keep our sensitive information secure and organized. Next, let's add page and group to the dependency array in useEffect. I mean here, we need page and group. So adding page and group here allows useEffect to rerun every time these variables change. This means that whenever the user selects a different category or moves to another page, the getMovies function will automatically fetch new data based on the updated page and group values. This keeps our displayed movies in sync with the selected navigation options. So to ensure that the navigation component has access to these variables, we will pass down page, set page, and set group as props. So down below, we have to add page with the value page. So passing page allows us to display the current page number directly in the navigation component. Next, we need set page with the value set page. Set page lets us control the page value from within the navigation. And finally, we need set group with the value set group. It allows the category selection to be updated from navigation. These props make it possible for navigation to manage both page and category, ensuring it functions seamlessly with the main content area. So inside navigation, we'll extract these props by adding them to the functions parameter. I mean, here we need page, set page, and set group. So this extraction lets us use the values and functions passed from home.jsx file and apply them in our navigation controls. Now let's make our navigation arrows functional by adding on-click event handlers to the left and right arrow span elements. So here I'm going to add on-click. Then we need to pass here a callback function in which we have to insert the following condition: page not equals to 1 and set page. We need again a callback function with the page parameter, and we have to return page -1. So when the user clicks the left arrow, the code checks if the current page is not equal to 1. This part, page not equals to 1, is a condition that prevents users from going below the first page, ensuring they don't encounter non-existent or invalid pages. If the page value is greater than 1, meaning the user is on page 2 or higher, the condition evaluates to true and allows the next part of the code to run. If the user is already on the first page, the condition evaluates to false and no action is taken, keeping them on the first page. If the condition is met, the code then calls the setPage function to update the current page number. Inside setPage, we use an arrow function that takes page as a parameter and returns page -1. This decreases the page number by 1, effectively moving the user back to the previous page. Because React automatically re-renders the component when state changes, updating page in this way triggers a re-render, refreshing the displayed data based on the new page number. Now, we need the similar thing for the second arrow. So I'm going to add here, again, on-click event handler. Actually, we need here on-click. Then I'm going to pass here, again, a callback function. And here we need setPage with a callback function with the parameter page. And then we have to return page +1. So when the user clicks the right arrow, the code calls the setPage function. The purpose of setPage is to update the current page number in the component state, allowing us to load new content or data for each page. Inside setPage, we use an arrow function that takes the current page value as a parameter and returns page +1. This incrementally increases the page number by 1, moving the user forward to the next page. So the arrow function here ensures that each time the user clicks, the page state updates to one number higher. React's state management automatically re-renders the component with this new state. So after the page state is updated, the app re-renders and displays the content for the new page. Alright, now we have to replace this hard-coded page number 1. So instead of 1, we need page. Let's go to the browser. So actually something's wrong here. Let's inspect the page, check console. We have syntax error, unexpected token, home 33 line. So let's check what's happening here. We have console error on this line. So here everything seems to be correct. Let's go to env file. We have here API key and the URL. Actually, we have here a mistake. This file should be placed here in the main directory, in the root directory. So as you can see, now we have here the response. Let's check if the pagination works. So as you can see, we are getting here different movies on each page. Okay, so everything works perfectly. Now we have to take care of the drop-down menu, I mean the options that we have here. So let's close console, go back to the VS Code. So we need to make the category drop-down functional by adding 2 key attributes. Let's close this env file. So here we have to add 2 attributes to the select element. The first one is going to be default value, and it's going to be popular. And then I'm going to add here onChange event handler. We need here a callback function with parameter e, which is an event object. And now inside this function, we need setGroup with the value e.target.value. And then we need setPage to 1. All right, so when the user selects a new option from the drop-down menu, the onChange event fires. This triggers the arrow function, where E represents the event object associated with this change. Within this function, two important actions occur: updating the selected category and resetting the page number. The first line inside the function, setGroup, retrieves the value of the selected option from the event object and uses it to update the group state. By calling setGroup with the new value, we are updating the category of content displayed in the app to match the user's selection. This dynamic update allows the app to fetch data that matches the new category, so the user immediately sees relevant content. The second line, setPage, resets the page state to 1 each time a new category is selected. This reset ensures that when the user switches categories, they start from the first page of results rather than staying on the current page, which may not make sense for a new category. Resetting to page 1 maintains a smooth user experience by displaying the beginning of each new category rather than potentially empty or unintended results. All right, let's go to the browser. So by default, we have here popular. Let's select top rated. Now we have here different collection. I'm going to go to page 2 or maybe 3. Then select different category, upcoming. As you can see, the page is reset to 1 and we have here different category, which is upcoming. Okay, so everything works perfectly. So now it's time to move on to the next step, where we're going to add some interactive effects to our navigation arrows to make them feel more dynamic and responsive. I'm going to create a hover effect using Framer Motion. To achieve this, we'll start by importing motion from Framer Motion. So here we need import statement, then motion from Framer Motion. So as remember, this motion component allows us to add animations and effects directly to our elements in an easy React-friendly way. Next, we'll wrap the arrows span elements in motion span components, which gives us access to Framer Motion's powerful animation capabilities. So here we need to add motion. This simple change lets us use attributes like initial and while hover directly within the element, allowing us to define animations that trigger under specific conditions. So here I'm going to add initial, and it's going to be scale 1. Then after initial, we need while hover. And here I'm going to insert scale with the value 1.3. All right, so to create the hover effect, we set the initial attribute to scale 1. This means the arrow will start at its original size, providing a stable starting point for our animation. The while hover attribute is set to scale 1.3. This tells Framer Motion that whenever the user hovers over the arrow, the scale should increase to 1.3, making the arrow slightly larger. All right, let's go to the browser. So as you can see, we have here nice hover effect. Actually, I think that we need here some space between the arrows and the page number. So let's check the classes. So as you can see, we need here space. That's why we don't have the space between the elements. Okay, so now we have much better results. And as you can see, we have here nice and cool hover effect. All right, so in the next part of the project, we're going to add some dynamic mouse move effects to make our interface feel more interactive and responsive to user movement. This effect will allow elements to respawn smoothly to the cursor's position, creating an engaging experience where the content seems to move slightly with the user's mouse, adding a subtle yet polished feel to the app. To achieve this effect, we'll start by setting up a state variable and a reference. So let's go back to the VS Code and in the home.jsx file, create a new state variable. It's going to be mouse position. Then we need an updater function, set mouse position. It should be equal to useState. And then we need here the default value and objects in which we will have 4 different properties. The first one will be left with the value 0. Then we will have top with the value again 0. Next we need width equal to 0 and then height again with 0. So the mouse position state object contains 4 properties. The left property represents the x-coordinate of the mouse on the screen, showing how far the cursor is from the left edge. With this value, we will be able to horizontally align our elements in response to mouse movement. The top property holds the y-coordinate of the mouse, or how far the cursor is from the top edge of the screen. Just like left helps with horizontal alignment, top will help us adjust elements vertically based on the mouse's position. The width property holds the width of the reference element, in this case the area we want to move in response to the cursor. Having the width stored in mouse position helps us keep the alignment and movement within the bounds of our selected element, keeping it visually centered and responsive. The height property holds the height of the reference element. By knowing the exact height, we can adjust the vertical movement in proportion to the element's actual size, ensuring a balanced, natural motion effect. Together, these 4 properties give us everything we need to track the mouse's position relative to the reference element and smoothly translate that position into an animation effect. Next, let's set up a reference which will let us interact directly with our chosen element in the DOM. So here I'm going to create a new variable and it's going to be cardsRef, which should be equal to useRefHook with the value null. Then we need to import useRef from React. So the cardsRef reference allows us to directly access the specific DOM element we want to move in response to the mouse's position. This reference is essential because it provides a direct link to the actual element without needing to manually look it up in the DOM each time. With cardsRef, we will be able to read and measure the element's properties, such as width and height, quickly and efficiently. Now, we have to attach this reference to our primary container or card wrapper. So here we need to add ref, which will be equal to cardsRef. So again, by attaching this reference to our primary container, we'll track the mouse's position relative to this element, making sure the animation stays within its bounds. Now let's go ahead and create a function that will allow us to track the mouse's position within our app in real time. This function is essential for capturing the exact location of the mouse as it moves across the screen. So, by knowing the mouse's position relative to our target element, we will be able to create a responsive effect where the content can subtly shift based on cursor movement, adding that extra layer of interactivity and polish to the user experience. So, to get started, we will define our function and set up 2 parameters. So, let's go ahead and create new function. Call it getMousePositions. We need here an arrow function. So as I said, I'm going to pass here 2 parameters. The first one is going to be event, and then we need reference element. So here, parameter represents the event object that's triggered each time the mouse moves within the defined area. This event object contains useful properties about the event, including details about the mouse's location. The second parameter, reference element, will represent the specific DOM element we want to track within. In our case, this will be the main container or wrapper around our cart. By providing this reference, the function can base its calculations relative to this exact element, making the effect precise and contained. So inside this function, the first thing that we will do is create a variable named positions that will hold the current x and y coordinates of the mouse on the screen. So let's create a new variable, call it positions. As I said, it's going to be an object. And here we need x equal to e.clientx. And then we need y e.clientY. So the x value represents the horizontal position of the mouse relative to the left edge of the viewport, while the y value represents the vertical position relative to the top edge. These values allow us to pinpoint the mouse's location on the screen at any given moment. So storing these coordinates in the positions variable helps us centralize the raw data, making it easier to work with as we move forward in the function. Next, we will define a second variable, offset, which will store not only the x and y coordinates, but also details about the dimensions of our reference element. So down below, I'm going to create another variable. It's going to be offset, which will be, again, an object. And inside here, I'm going to insert 4 properties: left, top, width, and height. Left position is going to be positions.x. So the left property holds the x coordinate value from positions.x, meaning the horizontal position of the mouse. Then we need top positions.y. The top property holds the y coordinate value from positions y, representing the vertical position. Together, these give us the exact location of the cursor relative to the viewport. Next, we need width, and it's going to be reference elements dot client width. So here, the width property pulls the client width of our reference element using reference element dot client width. This gives us the exact width of the element we are tracking, allowing us to keep our movement effect bounded within its horizontal space. And finally, we need height, which is going to be reference element dot client height. Similarly, height retrieves the element's height with reference element dot client height, letting us control the effect within the vertical boundaries of the reference element. By combining these 4 values, we gain all the information needed to dynamically adjust the position of our content based on the mouse's movement. Now, we will use set mouse position to update our mouse position state with the values from offset. So down below, we need set mouse position, and I'm going to insert here offset. So calling set mouse position applies the x and y coordinates and the elements width and height to the mouse position state, ensuring that each time the function runs, our application's state is updated with the latest mouse position relative to our reference element. This allows the component to re-render with these new values, which is essential for achieving real-time effects that respond instantly to the cursor. Finally, we need to trigger this function whenever the mouse moves within our main wrapper element. So in order to do this, we will add an onMouseMove event handler to the div element, where we will call the getMousePositions function each time the mouse moves. Let's go down and here use onMouseMove event handler. I'm going to insert here a callback function with an event object, and then we need getMousePositions function. As the argument, I'm going to insert here e, and then cards ref.current. So we pass e as the first argument to represent the event, and then we pass cardsReference.current as the second argument, to specify that we want the function to operate based on the exact element. So in React, when we create a reference using useRef, what we get back is an object with a property called current. This current property is special because it acts as a direct link to a specific DOM element, essentially giving us a live snapshot of that element at any given time. Unlike regular variables, current can store this element even across re-renders without losing its value, making it extremely useful for accessing or modifying DOM elements in a React-friendly way. In this context, cartReference.current allows us to target our primary content wrapper, the container holding our cards, and interact with it directly. So, with this setup, each time the mouse moves within the wrapper, getMousePositions runs, captures the coordinates and element size, updates the mouse position state, and triggers a re-render with the updated data. In order to test how this works, I'm going to pass console.log in the function. Let's insert here console.log. And then I'm going to add here mouse position. Let's go to the browser, inspect the page. I'm going to reload the page and move mouse. So as you can see, the coordinates of the mouse cursor are updating instantly. And then we have width and height. They are fixed values. In this case, width is 2500 pixels. As for the height, it's 2600 pixels. So that's the way how those values work and how this function actually works. In the next part, we're going to set up motion values to enable smooth animations that respond to our mouse movements. To do this, we're going to use a function called useMotionValue from the Framer motion library. The useMotionValue function is incredibly useful for creating animations because it gives us a special type of value that can smoothly change over time. So first of all, I'm going to import useMotionValue from Framer motion. So unlike regular state values, which can only update on re-renders, motion values are optimized for continuous updates even between renders, making them ideal for real-time animations. With useMotionValue, we can define values that update as often as needed, and these updates won't slow down our application or cause unnecessary re-renders. So I'm going to create two variables, x and y. So we need here x, which will be equal to useMotionValue, and the default value is going to be 0, and we need y with the same value. So when we set up x and y variables, we're creating two motion values starting at 0. These represent the initial x and y position for our animations. The x and y variables will now hold dynamic values that can smoothly update as we move the mouse, allowing us to control the horizontal and vertical movement of our elements. Now that we have these motion values, the next step is to update them with the real-time x and y coordinates of the mouse. We will use the set method provided by useMotionValue, which allows us to directly set the values of x and y to match the cursor's positions. So down below, we need x.set, and here I'm going to pass mouse position dot left. Let's duplicate this line of code. We need y.set mouse position dot top. So by calling x.set, we are telling Framer Motion to update the x motion value to match the current left position of the mouse. Similarly, y.set updates the y value to match the top position of the mouse. These real-time updates ensure that as the mouse moves, the x and y motion values change instantly, enabling our animations to respond smoothly to every tiny movement of the cursor. So in summary, by setting up motion values with useMotionValue and updating them with the mouse's coordinates, we are creating a system that allows for fluid and continuous animations. So now it's time to activate the mouse move effects so our content can follow the cursor smoothly as it moves across the screen. To make this happen, we will need to introduce a few new state variables and functions, all working together to ensure that the effect feels fluid, natural, and responsive to the screen size. So first of all, I'm going to create two state variables called window width and window height. So let's go ahead and create here new state variable window width. Then we need set window width. Actually, we need here a window. It's going to be equal to uState. And as the default value, I'm going to insert here window dot inner width. Let's duplicate this line of code and change width into height. We need here set window height, and also we need here inner height. Okay, so these variables will store the current width and height of the window in real time by initializing window width with window.innerWidth and also window height with window.innerHeight. We are essentially capturing the dimensions of the viewport as soon as the component loads. Now, why do we need these variables? Since our mouse move effects rely on the window's width and height to calculate the translation, we need to keep these values up to date, especially when the window resizes. Without this, the translation would remain static and our effect would break when the viewport changes. So with our state variable set, the next step is to introduce a function called useTransform. This function is incredibly useful for transforming one set of values into another in a smooth and dynamic way, which is perfect for our purpose here. So first of all, I'm going to import useTransform from FramerMotion. useTransform allows us to take an input value like the X or Y position of the mouse and map it to an output range, such as the movement of our element. Essentially, it takes the input values we define and translates them into output values that we can use to control the position of the element. So let's create a new variable. It's going to be translate X. It should be equal to useTransform. And here, I'm going to insert X. Then we need here 0, window width. And after that, I'm going to pass here, again, 0 minus mouse position dot width plus window width. So we start by using X as the input value, which represents the current horizontal position of the mouse. We map this from an input range of 0 to window width, meaning that as X changes from 0 to the full width of the window, the output value will adjust accordingly. For the output, we set a range from 0 to minus mouse position.width plus window width. Here is what this means in simpler terms. As the mouse moves from the left edge of the screen to the right, translate S calculates the new position relative to the width of the screen, adjusting the effect to ensure it stays centered within the screen width. By subtracting the width of the reference element from the window width, we create a balanced, bounded effect that feels responsive and doesn't shift the content out of the view. Similarly, we will set up translate Y. So I'm going to duplicate this line of code. We need here translate Y. Then again, useTransform. Instead of X, we need Y. Next, we need 0 window height. And here we need minus mouse position dot height plus window height. Now for translate Y, we are doing something similar but focused on vertical movement. we set up translate y with y as the input, representing the mouse's position along the vertical axis. Again, we use 0 to window height as the input range, meaning that as y moves from the top to the bottom of the screen, the effect stays proportionate to this full range of movement. The output range in this case goes from 0 to minus mouse position.height plus window height. This allows translate y to respond accurately to the vertical distance the mouse travels, staying within the top and bottom boundaries of the window and keeping the animation responsive to the viewport size. So, in short, both translate x and translate y dynamically calculate how far the element should shift based on the mouse's movement, making sure the effect stays centered and responsive within the full width and height of the viewport. Alright, next let's apply these translations to our main wrapper elements. To do this, we first need to wrap the element in a motion div. So let's go down and wrap that div element with motion div. Actually, we need to import motion from framer motion. And now let's go back to the div element. Here in the style attribute, we need translate x with translate x value. Actually, inside the object, if the property and value are the same, we can leave here just translate x, and in the same way we can insert here translate y. So this tells framer motion to apply our transformations to the wrapper in real time, so the wrapper moves fluidly based on the mouse's position, creating the smooth and dynamic feel. Alright, let's go to the browser. So we have here an error. We have a reference error, y is not defined. 47th line. So we need here lowercase, y not uppercase. Now it should work. So as you can see, once we move mouse, then the cards are moving. So as you can see, everything, and we no longer have here the errors. So the content now follows the cursor in a smooth, engaging way. However, to keep the experience clean, we will hide any scroll bars by setting overflow hidden on our wrapper. We will also add positioning classes to make sure the wrapper stays locked in place and fully covers the viewport, giving us a seamless effect without any unwanted scrolling or shifting. So let's go back to the VS Code and add here position fixed, then top and left properties, both of them 0, and also, as I said, we need overflow hidden. Let's go to the browser. So as you can see, we no longer have here the scroll bars and everything works fine. Now I'm going to close developer tools. So as you can see, once we change the size of the screen, once we close the developer tools, then we have here the space at the bottom. So this happens because the values for window width and window height are static and don't automatically update when the window resizes. So if the screen size changes, our calculation for translate x and translate y are based on outdated dimensions, causing the translation effect to misalign with the new viewport size. To fix this, we will add an event listener for the resize event on the window. So let's go back to the VS Code, and right after here, I'm going to attach an event listener to the window object. The event is going to be resize. Then we need here a callback function, which will be executed once the window is resized. So here we have to update window width and window height state variables. So therefore we need here set window width. And as the value, I'm going to insert here window dot inner width. Let's duplicate this line of code and change width to height. This event listener will trigger every time the window is resized, updating the window width and window height state variables with the new viewport dimensions. By doing this each time the screen size changes, these functions will run, updating the state with the latest values. Alright, so let's go ahead and test. I'm going to reload the page. Now let's actually resize the window. Inspect the page. Reload the page. So now, as you can see, we no longer have here the space, and actually everything works perfectly. Now it's time to take our mouse move effect to the next level by adding spring animations. This will make the movement feel more natural and fluid, adding a bit of bounce and resistance that gives the effect a smooth, polished finish. To do this, we're going to use the useSpring function, which is perfect for creating dynamic, spring-based animations that feel responsive to user interaction. Let's go back to the VS Code. So the useSpring function from Framer Motion allows us to add spring physics to any value. Instead of instantly changing from one value to another, useSpring creates a natural easing effect, where values accelerate and decelerate just like a spring would. So to start, we will import useSpring function from Framer Motion. And then down below, I'm going to create two variables. The first one is going to be xSpring. It should be equal to useSpring function. And here I'm going to insert x. Then we need an object in which we need to pass two properties. The first one is stiffness. The value will be 10. And then we need damping with the same value 10. Let's duplicate this line of code. We need here ySpring. I'm going to insert here y. As for the values of stiffness and damping, they will be the same. Okay, so with xSpring, we take x as the first parameter, meaning useSpring will apply its animation effect based on our x position. The second parameter is an object where we define specific spring properties. Here we set stiffness to 10, which controls how rigid the spring is. Lower stiffness values mean the animation will be looser and more bouncy, while higher values make it stiffer. By setting it to 10, we are creating a spring that's responsive without too much bounce, giving us a nice controlled effect. The second property, damping, is set to 10. Damping controls the friction of the spring, essentially how quickly it comes to a stop after it's released. A low damping value allows the spring to vibrate longer, creating a more dramatic bounce, while a higher damping value makes it settle faster. So now, in order to apply those values, actually those animations, to our mouse move effect, we need to replace those x and y values with xSpring and ySpring. Now, let's go to the browser. So, as you can see, we have here this nice and cool mouse move effect. Alright, now let's enhance the visual appeal of our cards by adding a fade-in effect as they load onto the screen. I mean, once we reload the page, the cards should appear with some fade effect. This will give the cards a polished, dynamic entrance, making the loading experience much smoother and adding a subtle touch of animation that catches the user's eye. To implement this, we will start by wrapping each card's div elements in motion div. So we have to add here motion. Once motion div is in place, we'll set three attributes: initial, animate, and transition. So here I'm going to add initial, in which I'm going to pass opacity, 0. Here we define the card starting state before the animation begins. By setting the opacity to 0, we make each card completely transparent at the start. Next, we need to add here animate. And here I'm going to pass opacity 1. So using this attribute, we make the cards visible. And finally, we need transition. And here I'm going to insert delay with the value I multiplied by 0.05. So this attribute adds a slight delay to the animation of each card based on its index in the list. By multiplying the index by 0.05, we are essentially staggering the animation so that each card appears one after the other with a 0.05 second delay between each. This staggered effect gives the cards a cascading appearance, making the animation feel more intentional and giving users a pleasant visual flow. Now, let's go to the browser, reload the page. So, as you can see, we have here this nice and cool fade effect. Alright, so now it's time to set up a loader to enhance our application's user experience. Adding a loader serves as a visual cue informing the user that content is being fetched and that they should wait momentarily. Without a loader, users might think the app is unresponsive or broken, especially if there is a delay due to network speed or a large amount of data being fetched. Our loader will display a message while the data loads and then hide automatically once everything is ready. The loader will be triggered whenever we initiate a data fetch from our API, ensuring that users see it only when necessary. So to start, we will create a state variable called loading. So here I'm going to create new state variable. It's going to be loading. And then we need an updated function, set loading. I'm going to set it to useState with the default value false. So this loading variable will control whether the loader is displayed or hidden, switching to true when data is being fetched and back to false once the fetch completes. By toggling this variable, we create a simple mechanism for showing or hiding our loader as needed. Next, let's go ahead and set up the loader's content right after our navigation in the JSX. So here down below, after navigation, I'm going to open div tag with the classes HScreen, which means height, with the value 100 viewport height. Then we need width screen. It means that width will have 100 viewport width. Then we need flex layout. Let's add here flex. Justify center. Items center. And also I'm going to change the background. Let's make it 240000. Inside the div element, I'm going to insert h1 heading and I'm going to add here classes. Let's change the color of the text, make it white. We need here text white. Then I'm going to increase the font size. Let's make it text 4XL. And then we need uppercase. As the content, I'm going to insert here loading with 3 dots. Let's go to the browser. So as you can see, we have here loading in the center of the page. So once we've created the loader content, we will need to control when it appears. Right before making our API call, we will set loading to true. So here inside the getMovies function, before we make the API call, I'm going to set loading. Actually, we need here set loading to true. This activates the loader immediately, displaying it on the screen and letting users know that the app is fetching data. Then as soon as the data has been successfully fetched, we want the loader to disappear, returning the focus to the newly loaded content. To ensure the loader hides once data is ready, we will use the finally block within our try catch statement. So here we need to add finally and I'm going to set loading to false. So adding set loading false inside the finally block guarantees that no matter what happens, whether the data fetch is successful or encounters an error, the loader will be hidden afterward. The finally block runs after both try and catch complete, so it's ideal for cleanup tasks like turning off the loader. This way the loader won't remain visible if an error occurs, which could otherwise make the app feel stuck or confusing to users. Finally, we will make the loader display conditionally. So we have to wrap the loader and main content inside a conditional expression, and we have to check the loading state. So down below, I'm going to open curly braces and then check if loading is true or false. We need here a ternary operator. If it is true, we have to display those elements. And if it is false, we need to display this entire motion div here. Okay, so again, if loading is true, we'll display the loader content. Otherwise, the main content wrapped in motion div will display as usual. This approach allows us to toggle between showing the loading screen and the main app content based on the loading state, providing a seamless experience for users. So I'm going to add here one more thing. As you remember, we added here initial and animate attributes. So in animate attribute, we have opacity 1. So this allows us to display the cards, but while the loading is displaying, we don't want to display the cards. Therefore, we have to add here conditional expression. We have to check if loading is true or false. So if loading is true, we need here 0. And if it is false, then we have to display the cards. Let's go to the browser, reload the page. So the loader is displayed and then the cards appear with nice and cool fade effect. Let's select different categories. So as you can see, loader works perfectly. The same happens once we go to other pages. Alright, so after setting up the loader to give users visual feedback while data loads, now it's time to add an abort controller to improve the way our app handles API requests. This controller will help us manage multiple fetch requests efficiently, preventing older or unnecessary requests from loading data that's no longer relevant. By implementing Abort controller, we ensure that each data request remains synchronized with the latest user actions, optimizing both performance and user experience. When working with apps that fetch data in response to user actions, there can be times when multiple requests might happen in quick succession, like when changing pages or filtering data. This can lead to data conflicts or unnecessary network load. So, by using an abort controller, we can cancel any previous request before a new one is sent, ensuring only the most recent request is active. So let's go ahead and start setting up the abort controller. First, we will add a reference for abort controller. So here, I'm going to create new variable, and it's going to be abort controller. It's going to be equal to userref, and as the default value, I'm going to insert here null. So this reference will store our active abort controller instance, which we will reuse for each request. Right before making our API call, we will check if abort controller reference.current already contains an active controller. If it does, this means there is a request in progress, so we call abort to stop it. So here, inside the getMovies function, I'm going to insert abort controller. Actually, we need here reference. Let's add here ref. So we need here .current, then not equals to null followed by an operator, and then we need abort controller ref.current.abort. Alright, so this prevents any previous request from completing and loading data we no longer need. After stopping the existing request, we create a new abort controller instance. So right after this line of code, we need abort controller ref.current equal to new abort controller. This new abort controller will handle the next request, allowing us to cancel it if needed. Next, I'm going to add the signal to our fetch request options. So here, I'm going to add signal, which will be, actually we need here L. So here we need abort controller ref.current, then not equals to null, and we need abort controller ref.current.signal. Alright, so this setup is essential because it directly connects the fetch request to the abort controller, allowing us to control the lifecycle of that request. Here is how it works in detail. The signal property in the fetch options requires a signal object from the abort controller, which provides the request with a listening mechanism for any potential cancellation signals. By assigning signal to abort controller ref.current.signal, we connect the ongoing request to our current abort controller, giving us control over that specific request. The condition here serves as a check to ensure that the connection only happens if we have a valid controller instance available. This means that it verifies whether abort controller ref.current holds an active abort controller before trying to link it to the request. In practice, this setup is valuable because if we call abort, the fetch request immediately stops. This not only saves resources but also prevents outdated or unnecessary requests from completing, ensuring only the most recent data is fetched. So this conditional approach also adds a layer of safety as it prevents errors that could occur if we attempted to assign a signal without a valid controller instance. Alright, so I know that it might be a little bit hard to understand, but don't worry, just add this code because it allows us to avoid having multiple unnecessary requests. Finally, we have to modify our catch block to handle any errors specifically from aborted requests. So in the catch block, here we have to add if statements in which we have to check if error.name equals to abort error. If this condition is true, it tells us that the fetch request was intentionally cancelled, not because of a network issue or some other error. So we have to log to the console aborted. And then we have to add here return. So we log aborted to the console for clarity and then return immediately to prevent any further error handling. Handling abort error in this way keeps our error handling clean and focused. Alright, so let's go to the browser and check if everything works fine. So as you can see, the mouse move effects work fine. If we go to different pages, then everything will work fine. Let's select different categories. Okay, so everything works perfectly. We've done an incredible job building this app, but now we are at a crucial step that will take it to the next level, making it responsive. In today's world, people are accessing apps on a range of devices from large desktop monitors to tablets and small mobile phones. We want to make sure our app looks good and functions perfectly, no matter what screen it's on. So let's dive into making our application responsive so our users have a smooth experience on any device. First of all, I'm going to inspect the page and switch to the responsive mode. So I have prepared a range of screen sizes that represent some of the most commonly used devices. We will be covering 6 different desktop screen sizes, 2 tablet sizes, and 3 mobile sizes. This variety ensures that our application is optimized for different layouts and that we're ready to deliver a consistent experience across all these devices. So we'll be setting up our responsive styling with a desktop-first approach, which is a bit different from Tailwind's default mobile-first style. This approach lets us focus first on the larger desktop layouts and then adjust for smaller screens. To get started, we need to make some changes in our Tailwind configuration file. Let's go to the VS Code and open Tailwind config.js. So, by default, Tailwind uses a mobile-first approach, meaning styles are applied to smaller screens first and then adapted to larger screens. However, in this project, we're going to reverse that and set up a desktop-first approach. This setup will make it easier to design our layout for larger screens first and then apply styles for tablets and mobiles as the screen size decreases. To do this, we will define specific breakpoints by adding a screens property. So here I'm going to add screens, in which I'm going to define different breakpoints. Let's start with XL, which is extra large. We need here max 1279 pixels. Then I'm going to add here LG, which is large. We need max 1023 pixels. Next we'll have MD, which is medium. We need here max 767 pixels. And finally, we need here SM, which is small. And I'm going to insert here max 639 pixels. Alright, so what this setup does is tell Tailwind that our default styles are for screens larger than these breakpoints, and for any screen smaller than the specified width, Tailwind will apply the responsive styles. So if the screen width is less than 1279 pixels, the XL styles kick in, and similarly for LG, MD, and SM. By following this desktop-first approach, we can design a layout that looks great on large screens and then make adjustments for smaller screens in a structured way. Once we've set up our breakpoints, the next step is to adjust our code so that the application can dynamically respond to changes in the screen size. To do that, we will use a useEffect hook to handle screen resizing. This is where we make our app listen for any changes in window dimensions and update the layout accordingly. This way, whenever the screen is resized, our app will adapt in real time without needing a full refresh. So, as I said, we have to use useEffect hook, and here, down below, I'm going to use useEffect. We need here a callback function, and then dependency array. Okay, so now we have to create a function called handle resize. This function should do a few important things. First, it should capture the current width and height of the window. This is essential because we will use these values to determine the layout and dimensions of our cards. So we need here set window width, and I'm going to insert here window dot inner height, actually not inner height but inner width. Let's duplicate this line of code. We need here set window heights, and then inner height. Next, we should set the default card width to 500 pixels. So I'm going to create new variable with let keyword. It's going to be new card width, and it's going to be equal to 500. The reason we create a local variable instead of directly updating the state variable card width is to avoid unnecessary re-renders while we're calculating the new width. When handle resize runs, we want to check and adjust the card width based on the screen size, but we only need to update the actual card width state at the end of our calculations, once we know what the correct value should be. So, by using a local variable, we can make multiple conditional adjustments without causing a re-render each time the width changes within this function. Once we have determined the final value for new card width, we then update card width state using setCardWidth function. So now we have to use a couple of different if statements in order to check the width of the window. So we need here if, in which we have to check if window dot inner width is less than 1280 pixels. If it is true, then we need new card width to be 400 pixels. So on relatively smaller screen sizes, we decrease the width of the card and we make it 400. Let's duplicate this line of code. Now we have to check if inner width of the window is less than 768 pixels. In this case, I'm going to make the width of the card 350 pixels. So again, here, when the screen size is below 1280 pixels, we reduce the card width to 400 pixels. And if it goes below 768 pixels, we set the card width to 350 pixels. These adjustments keep our layout balanced across different screen sizes without crowding or overlapping elements. Next, we have to update the card width. So, as we said, we need to use set card width. And we have to pass here new card width. After that, we have to update the wrapper width by multiplying the new card width by the number of cards in each row. So right after this line of code, we need to use set wrapper width. And inside here, I'm going to add new card width multiplied by cards in row. As you remember, cards in row is a variable which is equal to 5. All right, so this keeps the card containers width proportional and maintains our grid layout, making sure it adapts based on screen size. Lastly, we have to set the X and Y motion values based on the current mouse position to ensure that the animation effects stay smooth and aligned with the new layout dimensions. So right after this line of code, I'm going to insert x.set mouse position dot left, and then we need the same for y. We need here mouse position dot top. So we use these lines to ensure that our mouse tracking animations remain consistent when the window is resized. When the window size changes, the relative position of elements within the viewport also shifts, which could make our mouse-based effects look misaligned or out of sync with the actual cursor location. By resetting X and Y with the current mouse position values, each time the window resizes, we are effectively recalibrating the motion values. This recalibration ensures that our animations pick up smoothly from the mouse's current position after resizing, rather than creating a jump or visible misalignment in the animation. Now that we have completed the initial setup for our responsive design, it's time to dive into making our layout adjust smoothly whenever the screen is resized. First, we need to attach our handle resize function to a resize event listener. I'm going to grab this code from here and paste it here. And then I'm going to get rid of those two lines. Also, I'm going to get rid of this callback function. And instead of that, I'm going to insert here handle resize. This means that every time the screen size changes, whether we are moving from desktop to tablet or resizing the browser window, the handle resize function will automatically execute, recalculating all necessary responsive dimensions. To ensure everything is set up correctly right from the start, we have to call handle resize immediately after the component mounts. So we have to call this function here as well. So this initial call ensures that our layout adapts to the current screen size instantly, even before any resizing occurs. Next, to prevent potential memory leaks, we make sure to remove this listener when the component unmounts. We do this by returning a cleanup function in useEffect. So here, I'm going to return a callback function in which we need window.remove event listener. The event is going to be resized, and then we need here handle resize. So this cleanup step is crucial for optimizing performance and ensuring that our app only listens for resize events while the component is actively rendered. In JavaScript, global event listeners like window.addEventListener don't automatically stop when a component unmounts. This means that unless we manually remove these listeners, they will continue to run in the background. When components are removed from the DOM, for example, navigating away from a page or closing a model, this leftover event listener would still be active. So we need to return a cleanup function in the useEffect hook. Next, we move on to another important aspect of our responsive design. We use a second useEffect hook specifically to reset the X and Y motion values whenever the window dimensions change. So right after here, I'm going to use useEffect with a callback function and a dependency array. Inside here, we have to reset X and Y values using x.set. We need here 0. And then y.set with again 0. As for the dependency array, we have to insert here window width and window height. So why do we need this? Well, when the screen size changes, it can leave a residual offset, which might cause our layout to shift unexpectedly or show small gaps or spaces. By setting X and Y back to 0 each time the window size changes, we ensure the layout remains perfectly centered and aligned, eliminating any unexpected positioning issues. In this useEffect, we monitor window width and window height, so whenever these values update, our layout resets instantly to a centered position, providing a seamless, polished user experience. So, with our resizing logic solidly in place, we can now move on to adjusting the visual styling of our cards for different screen sizes. Tailwind CSS makes this incredibly convenient as we can directly add responsive utility classes in our JSX. For example, we will set the card height using responsive classes. So right now we have here height equal to 650 pixels, and I'm going to define LG breakpoint on which height is going to be 550 pixels. And then I'm going to define SM breakpoints, smaller screen sizes, on which height is going to be 450 pixels. Okay, so finally, we will also use Tailwind's hidden class to hide the summary text on tablets and smaller screen sizes. So here, I'm going to add LG breakpoint with hidden. Now let's go to the browser and check projects on different screen sizes. As you remember, I have here prepared different desktop screen sizes. Let's check the project on all of them. As you see, once we change the screen size, X and Y values, the positions, are reset. So still everything looks good. We don't have here any unexpected gaps and spaces. Let's check desktop 6. So everything works fine. After that, we have here 2 tablets. So as you can see, the sizes of cards are now smaller, And actually, we have here a little issue with genres. So let's go to the VS Code. I'm going to add here LG with 60, and also I'm going to add here flex wrap. Now the list should look fine. So as you can see, we no longer have here the problem. Everything looks good. All right, so let's move on and check other screen sizes. Tablet 2 is good. Next we have mobile screen sizes. So on mobile, everything looks perfectly. Then we have mobile 2. Still, everything looks good. Let's change the categories. So as you can see, everything works perfectly. Let's check mobile 3, which is the smallest mobile screen size. So actually, everything looks and works perfectly. Okay, so that wraps up our projects. Throughout this journey, we built a responsive, dynamic movie app that adapts to different screen sizes, utilizes smooth animations, and incorporates interactive mouse tracking effects. We explored powerful concepts like managing state, handling asynchronous data with API requests, and making our layout responsive using Tailwind's utility classes and custom configurations. So I hope this project not only helped you sharpen your React skills, but also gave you some new tools and techniques to enhance your future web development projects. If you enjoyed this tutorial, learned something new, or just loved seeing this project come together, please remember to like this video, subscribe for more content, hit the bell icon to stay updated on upcoming tutorials, and leave a comment with your thoughts or questions. I'd love to hear from you. Thank you so much for watching, and I'll see you in the next video.